All right, in this same section, now that we've been able to graph exponential equations, we also want to solve simple exponential equations. We don't have all of the tools yet to solve something like 2 to the x equals 5. We can't quite do that yet. In order to do that, we need logarithmic equations, which will come later. But we can guess that since 2 squared equals 4 and 2 cubed equals 8, that 2 to the x equals 5 is somewhere in the middle. In other words, 2 squared is 4, it's not quite enough to be 5, and 2 cubed is 8, it's too big to be 5. But we know that x must be between, well, it's not equal to because it's not 4. 2 is less than, x is less than 3. X is somewhere in between those. We don't have the tools to solve for that yet, but we will soon. But we can still make smart, assumptions based on what we do know. But what we're going to do today with solving exponential equations is solve ones that have a base of 2. Or a base of whatever our exponent has. So this didn't have a base of 2, that's why it's harder. It has, on this side we have a base of 2, and on this side we have a base of 5, and they're different, and that's why this one's hard to do. But we are going to solve beginner ones today, and I've got some rules set up for you on this side already. So first, we're going to isolate the exponential, get the x by itself. We're going to get the 2 to the x or 3 to the x or whatever base we have on one side by itself. Number 2, we're going to find a base for both sides. And number 3, if we've got equal bases, that means we're going to have equal exponents. So we're going to set the exponents equal and solve them. So if you look at this very simple example down here, if we have a base of a to the x and a base of a cubed, in order for the left-hand side to equal the right-hand side, x must equal 3. So we can solve for the exponents once we have gotten the same base at the bottom. So in our first example, we're trying to figure out what x is. So we need an exponent for it, for 25, in order for this equation to work. And we don't even have that particular term by itself. So number 1, isolate the exponential. We need to get 25 to the x by itself. We're going to keep it on the left-hand side and move 125 to the right-hand side. So now it's positive. Number 2, find a base for both sides. Well, the base is not 25. We've got 25 here, but we need to make it a different base because 25 to a power, like a whole number power, doesn't make 125. So this is hard right here. It's kind of like our first example where we have different bases. We need to rewrite these with a base that works. So I'm going to write, instead of 25 to the x, I'm going to write 5 squared. So I've got 5 squared x, and you'll notice that's the same. 125 is 5 cubed. So I've just replaced things in parentheses so it makes sense. And I've done this like this so I can make the next leap, which is this is 5 to the 2x, that's power of a power, means multiply. And I've got 5 cubed. So now I have a situation like at the bottom of my example on this side where I have the same base. And the base is 5. Therefore, I can go to the math, which is 2x equals 3. So divide by 2, x equals 3 halves. So what does that mean? That means that if I took 25 to the 3 halves power minus 125, I would get 0. So if I want to check that, I'm going to say 25 to the 3 halves power minus 125 equals 0. Again, I've always told you that I would like for you to do roots first. So write roots on the bottom so you know that that's the square root. So I've got the square root of 25 cubed minus 125 equals 0. The square root of 25 is 5 cubed minus 125 equals 0. And at this point, you know it's true. 125 minus 125 does make 0. So you're all set. All right, for example 2, let's say we have 8 to the y minus 1 equals a half. 8 to the y minus 1 equals 1 half. So same type of problem. I have already almost isolated the y minus 1. I can't get the minus 1 to go away right here, so I'm going to leave it just like this and call this isolated. So I've already isolated my step 1 right here, isolated. I'm going to take care of the y minus 1 at the very last. But I don't have the same base. And this is where the base that I might choose might be different than the base that you would choose. I'm going to choose to do positive whole number bases, and they have to be positive because that's a rule, but instead of making this a half, I'm going to make them both into 2. So let me do this like I did the last one. I'm going to rewrite it with the things that I'm going to move around. Okay, so instead of 8, in parentheses, I can write 2 cubed. So I haven't done anything with that yet. I've just rewritten it in a way that is going to have a base of 2. On this side, I'm going to make this a base of 2. To do that, I say 2 to the negative 1. This is 2 to the first, and I move it to the top. It becomes negative 1. Now I have the same base, but before you do anything else and make a careless mistake, let's review the math rules. So right here, this is power of again. This is really 2 to the 3 times y minus 1, distributive property. So when I go to solve it, when I drop the bases and solve for the exponent, I'm going to have 3y minus 3 equals negative 1. And so I solve for this. I'm going to have add 3. I've got 3y equals 2, so y equals 2/3. So I've got a fraction answer there for y. I can plug that back in. I'm going to have, if I want to check it, that would be 8 to the 2/3 minus 1 equals 1/2. That's my original problem rewritten with 2/3 here for y. So that means 8 to the 2/3 minus 3/3 equals 1/2. That's 8 to the 2 minus 3 is negative 1/3 equals 1/2. So the negative means I need to flip this over. It's going to be 1 over the cube root of 8. Remember, like I did in the last problem, bottom numbers are roots. I did 2 things in one step. The minus puts it in the denominator. The 3 makes it a root. Is this true? The cube root of 8 is 2. This is 1/2 equals 1/2. So that works. So you do want to be able to understand the math enough to be able to check your work. So isolate, same base, do good math, use exponent rules, and then you can set the exponents equal to each other. So you're just solving, solve for the exponents in this sort of middle step before we go to check. Let's try another. So now I've got 2/3 the x equals 9/4. So think about that for a second. You can see the 2 and the 3 and the 9 and the 4. You can see the relationship there. It depends on how you want to flip them to figure out what you want to do in your next step. We have the x isolated. We need to have the same base though. We don't have that yet. So I'm going to leave this 2/3 to the x, and I'm going to aim to make this into 2/3. So first I need to flip it over. I'm going to say this is 4/9 to the negative 1 power. So negative exponent rules means flip over. I've still got 2/3 x over here. And if I think of this as being 2 squared and 3 squared, I'm going to make this 2 squared, 3 squared, all to the negative 1. I'm trying to write this out so you follow every step. So I kept the negative 1, that's this. And then I changed 4 into 2 squared. and 9 into 3 squared. The 2 applies to both, so now I have it like this. I now have the same base, so I can set the exponents equal to each other. I'm going to set the exponent on the left. X equals, this is power of a power, which is multiplication, -2, and that one's just done. That's the answer there. So x equals -2. So that means if you took this and flipped it over and then squared it, you would get 9/4. Some of these you may be able to work out in your head or guess and check, but guess what? I need to be able to see you get the same base and work out the math. So guess and check won't work. You need to have all the steps in order to get your solutions there. I've also tried to show you what this means graphically in other examples of problems that we've worked, and I want to do that here. So if you look back at example 2 here, what does this mean graphically? So if we take it, this same equation where we're trying to find the y value that makes this equal to this, let's graph it and see what we have. So I'm going to put on the calculator y1 is going to be 8, and in the calculator it's going to say x minus 1, and y2 is going to be 1/2. This is a straight line. This is an exponential that's been shifted right 1. So let's look for these two graphs and see where they cross. Where two things are equal in graphical sense means their intersection. So let's look and see if we can get the same thing in the calculator. So when I do 8 to the y minus 1, I'm going to put in 8, and then I'm going to say exponent with this caret symbol, and then x minus 1. That's my first graph. Let's just take a look at it and see if that's what we think it'll be. So it is an exponential. It grows very quickly because it has 8 as a base. The second, the y2 here is 1/2. So 1 divided by 2, or you could do a fraction. Oops, I just undid my thing. That was silly. Let's go back. 8. Delete, delete. Okay, sorry. My y2 is supposed to be 1/2, so 1 divided by 2. And I graph both of them together. And I have a straight line at 1/2, just like I thought. And we're trying to see where they cross. So that's an intersection, just like I wrote here, intersection. Second, calculate, intersect is 5. Blue to red, intersect is going to be 0.66. Repeating, which is 2/3, our answer here. Same thing would go here, 2/3 to the x. But let's see how we put in the second one into the calculator, make sure we do everything correct. So I'm going to clear it out. So hopefully I won't make that same mistake again. On paper, I'm going to think about y1 being 2/3 to the x and y2 being 9/4. So again, this is a straight line. It's a horizontal line that crosses at 9/4. So this time I want to put in parentheses and put in my fraction. I'm going to do as a fraction this time. So 2/3. Thirds, and then outside the parentheses, I'm going to put x. Now it's an exponential, and the whole thing is to the x power. The second one is 9/4, which you can do as a fraction, or you can just write it as 9 divided by 4, and graph these two guys. Notice how this is decay, because the base is 2/3, which is less than 1. So this is decay. It crosses 9/4, and it should be at -2. So this value here is at -2. We're going to confirm that by intersection, and intersection's at -2. So graphically speaking, that's where the left side equation equals the right side equation. That means two different graphs and where they cross. All right, so you've got practice in this where you're getting the same base. You might need to play with your bases a little bit. You're going to have to think about what the numbers have in common so you can get down to that lowest base. Please do take an extra step if you need to, like we did here where we flipped it over first and kept the -1 for the flip, and then brought it down to what number squared made 4/9. So take all the steps that you need in order to get the right exponent and not do anything goofy along the way. All right, so good luck, and let me know what questions you have. Thanks.